Good morning, learners. Today we will be dealing with momentum and frames of reference. So we will get on straight away. These are some of the important notes that I would like to go through with you as we highlight this section on momentum and frames of reference. The key thing when we deal with momentum will be to look at the direction, and just like in the other areas in mechanics, you have to determine the direction yourself. So the direction is actually your own choice. So you decide which direction you want to take. For example, if you choose the direction east as positive, then what you have to do is, that is the direction that you as a learner has chosen. Now you will determine the direction of the other objects. Like for example, if a car is moving in that direction with a velocity of 5 meters per second, you will compare the velocity or the direction of the velocity of the object with the direction that you have chosen. Since this car is moving in the direction east, then this car will have a positive direction because it's moving in the direction that you wanted, you chose as positive. For a car that is moving in the opposite direction, in this case west, then your direction relative to the direction that you have chosen will be negative. You do not need to worry about the direction that you choose. The reason being that when your scripts are being marked, there are options that are given for you which take into account the direction that you choose. So if another learner chooses west as positive, then that learner will be catered for. So yours is just to be consistent with the direction that you have chosen, and then work out the problems that you are solving using the directions of the objects relative to the direction that you have chosen. Now, when you get to the final answer, remember that your final answer will either be positive. Say in this case, your final answer, if you are looking at the velocity, is 2 meters per second. If the final answer is positive, then that answer is in the direction that you chose to be positive. So that means that your object will be moving in the direction that you chose, which will be east. Conversely, if your answer to the question is negative, then you interpret that negative answer so that we write it as a positive. We will therefore say that it is 2 meters per second. But now notice that the initial one was negative, meaning that we will say, since our initial direction of initial choice of direction was positive, is east, then negative will be west. So we write this as 2 meters per second in the direction west. This further emphasizes the fact that for mechanics, because we are dealing with vectors, whether it be vertical projectile, whether it be momentum, or it be frames of reference, we will be using these directions because we are dealing with vector quantities like velocity, like momentum itself, like the force. So in this particular case, whenever you are dealing with those vector quantities, you have to indicate the direction. Remember that a vector quantity has both magnitude and direction. So it is important that you choose your own direction. Having said that, we would also like to advise that examiners sometimes use different words to describe direction. For example, an examiner can use east, the word east. He can use west, or the examiner can choose to use right versus left. The examiner can choose maybe the direction towards the wall or away from the wall. Now what you have to do is, in your final answer, your direction should make use of the words that the examiner has used in the question. So if the examiner had used a statement like a car is traveling in the direction east or eastwards, then in your final answer, when you have to determine, say, the velocity of that car, then you must indicate whether the car is moving either east or west, depending on your choice of direction. But remember that the terms that you use, they should be the ones that the examiner has used in the question. In other words, it would not be appropriate when the examiner has used east or west for you to say left or right. If the examiner has used left or right, then for you in your answer, you should also use that. If the examiner had used, say, for example, towards the wall, then you can say, you can also say towards the wall or away from the wall based on your final answer. The other important point that we need to talk about is that you should not omit important words in your formulation of the laws. What do I mean by that? Let's take the law of conservation of momentum, for example. We know that the total momentum, if you have two objects, say this one is moving in that direction and that one also is moving in that direction. Before collision, we talk about the total momentum of these two objects. If you say that is M1 and that is M2, we are referring to the total momentum, not only the momentum of object A, or if you call that A and B. We are not only talking about the momentum of A, we are not only talking about the momentum of B. So we are referring to the total momentum of that system, of the two objects, before the collision takes place. And that total momentum before the collision takes place will be the same as the total momentum of these objects after the collision has taken place. The other key point that we should notice is that in order for momentum, for that total momentum to be conserved, the system of objects that we are talking about should be free of external forces. In other words, there should be no friction. such a system which is free from external forces we refer to as an isolated system. Now, we have said you must have total momentum. This is a key word. When you define or you state the law of conservation of momentum, you must indicate that the total momentum of an isolated system remains conserved. The total momentum of an isolated system remains conserved. That is, the total momentum before the collision is equal to the total momentum after collision, if the system is isolated. So these are keywords. If you, in your statement of this law, you leave out or you omit this total, you just say momentum before the collision is equal to momentum after the collision, or momentum is conserved. You don't indicate total momentum, and also in an isolated system, then you are going to lose marks on that. Perhaps while I'm still on the laws and definitions, it appears that quite a number of you learners do lose marks on definitions and laws, particularly because it appears that maybe you do not read or commit these laws to memory. Make sure that you understand, you know these laws, because you can get your free marks. Remember that each statement of a law gives you 2 marks, or each statement of a principle or a definition will give you 2 marks. So do not lose those marks. Make sure that you collect those marks. In this manner, you will find that in most of the questions that come, not only in momentum, the first question will ask you, for example, state the law of conservation of momentum. That question requires you to state the law. The second question will want you to be able to apply the law that you have stated. So the second question actually is an application to show that what you have stated, you really understand what you are talking about. So in the second question, you will find that they will give you a scenario where they expect you to apply the law of conservation of momentum. Now, one of the challenges that we see with that, if say for example we have that M1 and M2, we find that learners will just write P before, some will just write PB is equal to PA, and this is not taken, learners. We do not take that. In the application of this law of conservation of momentum, we say the momentum, in other words, the total momentum of the system before, and we write that in full, before the collision is equal to the total momentum after the collision. You can do this, or alternatively, if you don't do this, you can alternatively use the summation or sigma notation and say the sum of the momentum of the objects before the collision is equal to the sum of the momentum of the objects after. Then once you have done that, we will look at a later stage when we look at the problems, what you would do. Maybe you will look at M1 for the momentum of the first object, M1. Then you must indicate that you have the initial velocity for that original mass, the first mass, plus M2. Indicate that you are talking about the initial velocity for M2. That would be before a collision takes place. That will be equal to, depending on the nature of the collision, whether the objects attach to each other or they do not attach to each other, then you can have M1 V1 final plus M2 V2 final. So these subscripts are very important for you to put in to indicate the initial velocities of the object and the final velocities of the object. Usually when we mark, we will just check that this is correct, and if you have made any substitutions in the equation, then you will definitely get a mark for just representing that like that. These others will not get a mark once you have that one right, but your substitutions must be there in order for you to get a mark. I think that would be as far as what we realized as the necessary things that you need to do is concerned. I will highlight others as we go on with the presentation. Now to start, we are going to look at the frames of reference. It is important to notice that when we refer in frames of reference, we refer to the relative velocities of objects. If the velocity of object A with respect to the ground is given as VAG, or velocity of A relative to the ground is given as VAG, and the velocity of object B with respect to the ground is given as BG, then the velocity of object A relative to object B will be given by the velocity of A relative to the ground plus the velocity of B relative to the plus the velocity of the ground relative to B. Let me just write this correctly. AG plus VGB. This is the standard way of writing it, just to have the ground inside, so that outside here we have A outside, B, we have B outside. But we will notice that if you take VAG and you swap this subscript, if GB is positive, then BG will become negative, so you write that as minus VBG. And this is the easier way of dealing with the frame with the relative velocity, and this is the equation that we will commonly use to solve problems. With that, then it means we are ready to start with questions. I've picked a few questions here on frames of reference and relative velocity. Don't worry that it is number 13. This comes from a compilation of questions where we have questions on momentum and also questions on frames of reference. So I've opted to start with the frames of reference, and you will see that this section does not have many questions in the paper. However, it is also important that we understand, because those marks are also important, and above all, you are going to use that information also when you go to tertiary institutions. Now, the first question there that we have says, the diagram below shows two tracks P and Q. We have these two tracks P and Q. They travel in opposite directions along a straight level road. Track P travels at 15 meters per second and track Q travels at 10 meters per second. Let's just go back to what we said earlier, that examiners will give you directions and use certain words to indicate directions. If we look at this question, we have not been really given words like east or west to indicate the direction. So here you can choose your own direction. Now they say that a passenger on track P will a passenger in track P will observe track Q traveling at what velocity? Now, to emphasize on the idea of directions, it may be necessary that we do this question also following the same pattern. We can choose here, because the examiner has not given us any particular direction except that these are moving in opposite directions. We can choose, for example, say, let's make right as positive. If right, we take the direction to the right as positive, then we can work out the velocity of object P relative to the ground is given as 15 meters per second. The velocity of object Q relative to the ground is given as 10 meters per second. Then what does the question say? What will the passenger see about Q? In other words, this person is sitting in track P, then he observes Q moving. So we want the velocity of Q relative to P. In other words, what we are supposed to get is the velocity of Q relative to P, because this person, notice that if we say P relative to the ground, then this ground is the observer. Q relative to the ground is the observer. Here Q relative to P, P is the observer. This person is observing Q coming or moving away. We will see that in the final answer. Now the velocity of Q relative to P is what we are looking for. Therefore, we will say the velocity of Q relative to P is given by, I'll just take the last form of the equation, where we will say V Q relative to the ground minus V P relative to the ground. Now we have chosen our direction to the right. In other words, the one that is moving to the right is P as positive. So when we substitute here, we must indicate that as well. So Q relative to the ground is this one, which is 10 meters per second. Now let's check this track Q is moving to the left, so that velocity must be negative. Then we subtract. That velocity must be negative. Then we subtract the velocity of P relative to the ground, which is 15. That gives us negative 25 meters per second. How do we interpret this? This therefore tells us that the velocity is 25 meters per second. Because our right is positive, this will be moving in the direction left. Of course, here we are not given the directions, but I used this to emphasize the idea of using the direction or choosing the direction. Now, what can we interpret or what can we make, what sense can we make of this? When the person is sitting in this car, P or track P, he sees Q because P is moving in the direction right. The person in that car sees Q moving to the left, because it's moving, because Q is moving towards P. So this negative here tells us that the person in the track P will observe Q moving in the direction opposite to their direction. And I am sure you will also notice that in essence what we have got here is, if you add the 15 to the 10, you will notice that you get 25. In other words, if two objects or two cars are moving towards each other, their relative velocities will be, or the magnitude of their relative velocity will be the sum of their velocities with respect to the ground. That can be an easy way of just checking whether you have done that. And you will understand that if you have to add the two velocities, then how dangerous, if you take it to the real life situation, how dangerous two cars that are colliding head on can be, because you add the velocities. If, for example, I'm driving at 120 kilometers per hour on the N1, and another car is traveling at 120 kilometers per hour in this in the opposite direction, and our cars collide, then in essence the velocity with which the one car will hit the other will be 240 kilometers per hour, and you see how dangerous that can be. Hence why in practice you'll find that head-on collisions are very, 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 very dangerous. Let's look at question 14. What does question 14 say? Two cars, X and Y, are traveling easterly or in an easterly direction. Now here the examiner now gives us the direction along a straight level road as shown in the diagram below. The velocity of car X is 10 meters per second relative to the ground, and the velocity of car Y is 5 meters per second relative to the ground. So these cars are moving in the same direction. I think if it is like this, then it's easier to choose the direction in which both cars move, because your velocities will be in the same direction. So we can choose east, take east as positive. Now if you take east as positive, then the velocity, we are told that the velocity of x with respect to the ground will be the velocity of x relative to the ground is given there. It is 10 meters per second. The velocity of y with respect to the ground will be 5 meters per second. Now what do we have to find is the velocity of car x relative to car y. I have highlighted here velocity. Why have I highlighted velocity? Because now we are talking about a vector, and the examiner tells us that we should find the velocity. So the velocity is a vector quantity. It must have a magnitude and direction. As you can see, the answers, they indicate the magnitude, which is size, and the direction as well. Now let's see if we can be able to see which of these answers is the one we are looking for. We are looking at the velocity of car x relative to car y. So the velocity of car x relative to y will be given by, I'm just going directly now, the velocity of x relative to y will be given by velocity of x relative to the ground minus the velocity of y relative to the ground. Now when we substitute, let us remember that we said the direction to the east is positive. So velocity of x relative to the ground is 10. It's positive, it's in that direction, so we write it as it is. Minus the velocity of y relative to ground. The velocity of y relative to ground is 5 meters per second. So that gives us an answer of 5 meters per second. Our answer is positive. Now we compare that answer that we have with the initial original direction that we chose before we solved this problem. So east is positive, our answer is positive, so this car will be moving east. Let's take this to the cars on the road. Here, if you look at this, you realize if we see the velocity of x with relative to y, we are saying y is the observer here. So the person here in this car sees x moving at 5 meters per second in the direction east. In other words, you can see that it makes sense because the velocity of x is higher than the velocity of y. So x is approaching y. So our answer here is positive, indicating that y sees x as approaching. Perhaps for interest's sake, then we will see that if we look at that answer, then it gives A as the correct answer. For interest's sake, maybe we could also look at another scenario. Let's say, what would be the velocity of y relative to x? In other words, what would be the velocity of y as seen by x? Then we would say that the velocity of y relative to x will be given by velocity of y with respect to the ground minus the velocity of x with respect to the ground. And we just look at that, the velocity of y with respect to the ground, because it's east is positive, this is also going east, is positive, so we'll write that as positive 5 minus, now x relative to the ground is 10, it's positive, we write it as 10 positive. Now we see that our answer becomes negative 5 meters per second. And what does that tell us? We can interpret this to say that this velocity of y with respect to s is 5 meters per second. But because it is negative, we said east is positive, so this will be west. What does this mean to us? Remember, x now is an observer, and you must in one way or another have seen this situation. X is approaching y, so as x approaches y, he's about to overtake, he sees y moving backwards, and that is what that tells us, that y is moving in the direction backwards as observed by x, because x will overtake since he's driving at a higher velocity. So this was just out of context, just to illustrate the idea of relative velocities, and this is what we see in our daily lives. And so every time you get into a car, you see the car you are traveling in overtaking, remember that the car you are traveling in sees the other one as moving backwards. Okay, let's look at the next one. Fifteen. Here we have a girl who is sitting in a train, and the train is traveling at 100 kilometers east. I have indicated that east because that is the direction that the examiner has given us, so we can look at that as well. An aeroplane traveling west at 300 kilometers per hour passes overhead. So we have an aeroplane passing overhead. Now they say, which one of the following is the description of how the aeroplane is moving relative to the girl in the train? Let me highlight that this girl is in the train, and this girl is sitting here in the train. So the velocity of the girl, or the speed of the girl, relative to the train, will therefore be it will be 0. In other words, the girl is traveling at the same velocity as the train. So perhaps we should first start by checking our direction. We can take east as positive, or maybe for interest's sake we can take west. Let's take west as positive, just to accommodate others as well. Now we want to accommodate others and take west as positive. Now what we are saying is an object that is traveling in the direction west will have a positive velocity. So let's see the velocity of, I will use train here to represent the velocity of the girl, because this girl is traveling at the same velocity of the train. With respect to the ground will be, the train is moving at 100 kilometers per hour. The velocity of the plane, can I say plane or aeroplane, P, to represent the plane relative to the ground. And now, okay, let's write it as 300 kilometers per hour. Now we are required to find this description of how the aeroplane is moving relative to the girl in the train. Now we want the velocity of the plane relative to the train. That will be given by velocity of the plane relative to the ground minus the velocity of the train relative to the ground. Now we go back. Okay, we already have, no, we don't have that information. Let's go back here. The velocity of the plane relative to the ground, the plane is moving in the direction west, and that is the direction that we chose as positive. So we will write that as 300 positive minus the velocity of the train relative to the ground. It's 100 kilometers. Note that the train is moving in the direction east, but our choice of direction is that west is positive, so the train is moving in the direction east, which will therefore be negative. So this gives us 300 plus 100, which is 400 kilometers per hour. This is positive. What does it mean? We said west is positive, so the plane relative to the train is moving west. And that is true. That's what we see in the question there. The train is moving east, the plane is west. So the girl in here will see this train moving in the direction west, but at a higher velocity. Note that the plane and the train are moving towards each other, so we have basically added their velocities. So that gives us the answer there, which is A, 400 west kilometers per hour in the direction west. And the last one on the frames of reference is number 16. So here we are also given by the examiner that P, or car P, moves west at a speed of v. We are given the direction here as west and east, so that's what we should interpret our answer in that form. Then it's moving with the speed v, and car Q moves east. In other words, they are moving in opposite direction at speed 2v along the same straight road. The velocity of car P relative to car Q will be given now. I did not highlight this, but note we are also talking about the velocity, which is a vector quantity. So we can choose the direction. Remember, you choose the direction according to how comfortable you will be with that direction. don't worry that am I expected to choose east as positive or west as positive. With practice you will see which one you are comfortable with. So if we take, for example, east as positive, then we will say that car P, the velocity of car P relative to the ground is given as V. I should make a small v. And the velocity of Q relative to the ground is given as 2, or actually it's the speed as is indicated here, is as 2v. They are along the same straight road. Now we want the velocity of car P relative to car Q. The velocity of car P relative to car Q will be given by, so we use that formula, Vp relative to ground minus V Q relative to the ground. Let's check in our substitution. We take east as positive, hence velocity of P relative to G. P relative to G is V, and we are told in the question that P moves west. So if our east is positive, P is moving west, then this becomes negative V minus the velocity of Q relative to the ground. We are told that Q, according to this, moves in the direction east. East, according to our choice of direction, is positive. So this one is moving in that direction that we chose as positive. Therefore, it will be positive 2v. Now we just add this together. They will give us negative 3v. Of course, we have to interpret that Vp Q is equal to 3v. But we said east is positive, then negative means west, so it will be 3v in the direction west. Okay. So what do we do? This Vp PQ is equal to 3v. That means it's moving west. So we see that our answer there will be it will be 3v in the direction west. Let me pause at this point to look at a question that I have just received. And it's from Elena from Triving Secondary School. I don't know whether it's a she or a he. The question is, why did you say that the velocity of track Q relative to track P in question 13, track Q relative to P? Let's look at question 13. If you understood me correctly, my dear Lena, I said that when we write the velocity of, let's say, P relative to the ground, then we are saying if there is a person on the road here, which is the ground, observing P, then he will see P moving with this velocity. So P is seen by the person on the ground. The way we represent this as Vp, velocity of P relative to G, says to us P is the person who is seen to be moving, and G is the observer. The ground is the observer. The person on the ground is the observer. So, like we have said, this PG is 15 meters per second, and then Q with respect to the ground is 10 meters per second. Now what we are saying is P is in the car. I think that is what your question is. Why did you say that the velocity of track Q relative to track P? We are saying the passenger on track P will observe track Q traveling at what? So this passenger is the observer. In other words, we'll be saying the velocity of the one that is being observed, of Q, relative to that one of the observer, which is P. I think that makes sense. P observes Q coming, and that is why in my calculation I have said that if you look at the scenario, P is in this car, he sees Q moving in the direction to the left, because the answer that we get here is negative. In the direction to the left, since we said the direction to the right is positive. So P is moving to the right, but P sees Q moving in the direction left. Hence why we see that. So P is the observer, hence why P is placed here. Is the one that sees Q moving. I hope that clarifies it. P, the velocity of P relative to the ground, the one that we put as the second subscript there, is the observer, is the one which observes it. Some people say it's the stationary object, if you like. I hope I've addressed that. We are about to take a break. I think in trying to look at this, I've tried to highlight or emphasize again the importance of choosing the direction as you solve problems, because that will give you, especially when now you are dealing with vectors, the velocities and other vectors, you have to indicate both the magnitude as well as the direction. And that is important because it will give you the direction as well. Thank you. We will take a break.